Alright, this is a quick review of C. I will actually have the entire source code posted into the description if it fits. I'm using knowledge from previous mistakes and making sure you can see this, so the screen looks a little weird. I just got code blocks and I wrote a bunch of code in here. It took a little bit of time, not too much though. So this is just a review of C, mostly for coders. I'm going to go fast. I'm going to explain everything. This newbies can use this, but like I said, I'm going to go fast. This is an example of syntax. What I'm doing is I'm preparing anybody who's going to watch these so they can view this, which is just C, which is the foundation of Objective-C, which is the iPhone. And then I'm going to do two other languages and well, I'll keep it a surprise. So, while this is C code, you'll notice I use IOStream, which is C++. It's because I hate using printf. I'd rather use cout. So here it is. That should be the only change necessary for making this. And just a second. There. Now I can see what you see. Ah, okay. So, using namespace standard is C++. We can ignore that for now. All it does is make it so I don't have to fully qualify the name of cout using the global scope double colon operator, which is that. So I use some preprocessor macros, which I don't actually want to go over, but what I'm doing is showing the syntax mostly. The extern int e would go into a header file on something else, and that's when you define something that you want to be able to be used outside of this file, but it's going to be defined inside the file, so it'll actually have an int e in global scope right there, which you should not define things for most object-oriented languages outside of their objects, and we'll just consider main to be somewhat of fulfilling that function. So I did not assign e a value until I got into the main function right there. This is a function header. What I wanted to demonstrate was you just needed float and float. It doesn't matter what the names are. In fact, you don't actually need names in function headers of variables. It makes it a lot easier to read. You should do it. So like x and y or anything you want is what you should be doing. What I'm demonstrating is their actual syntax should run even without names up until the definition. And yes, it does. So I'll say A and C. Constant, just constants do not change. I believe they have a default value, but I would always qualify it with int or short or whatever you want it to be. I rarely ever use those. Just after programming for the iPhone for a while, just realized that. Float add. This is a function definition and header-ish. So the only thing the compiler wants to know is that it exists before you use it. So that's why the header's here. It's actually defined below main. Main's kind of big, and there's the definition. And I use multiply about halfway through, right there. We'll go over the output later. ACHOO. I didn't actually say. I just gave an arbitrary name, so yeah, it doesn't matter what you say this. And I know I went back just a little bit, but defining a preprocessor macro, it's just the same name no matter what. Okay. Enums. I did C-style enum, so I gave it a name of season. They go from 0 and up by 1 each by default, so these are all integer values. I made it start at 7 just to have some fun. Inline functions. You declare a function as inline and then it just expands itself, kind of like a define does. I'll have to let you go to another tutorial for those. There used to be a bunch of controversy over which was faster. I believe processors made so many advancements since then that if anybody's still arguing about it, they're just wasting a lot of breath. Typecasting. I didn't actually go over this, but essentially the compiler will default almost everything to int. Unless there is a float or a double, then it'll either default to double or whatever types you've defined. So if you want to divide two ints and return a float, you'll have to cast one of them simply by putting the type in parentheses next to it. And then the compiler says, oh, since one of them is a float, I'll make this value return a float. And you won't lose precision. Alright, so this is just basic printf in the C++ way. Way easier. Just straight left to right, and del is the same as the backslash n character. I use them interchangeably. I make the global e equals 5. Anyone reads Windows game programming. If anyone has read Windows game programming for dummies, they'll know that global ints are just faster than other variables, which is why they're used in game programming up until object stuff. So might want to get out of the habit for the mobile phone industry, so the iPhone and stuff. But anyway, unions, these are just structures. So I'll have something called U, it'll have F and B. The thing is, if I assign a value to F, then the space that B takes is taken because they both take the same space. That's why it's called a union. It's kind of like an elevator, and only one person can stand in it at the same time, and that person is either this variable or that variable or any other that you define. I believe unions are kind of expansive. They should be able to hold more than just these basic types, but I'm not too sure on that. I never use them, otherwise I'd be going over them more. So there's my comment. Like I said, this will be in the comments or the description of the video. So struct. These are value types. Unions and structs are both value types. You need to remember that when you get into pointers and references and classes. So a struct contains its own any members. It just doesn't contain functions. Not until you get into object-oriented languages anyway, which they should not contain functions, but they do, and there's a bunch of rules on it when they do. But anyway, you use the type def thing, so later you can just say ship small one instead of saying struct spaceship small one. So this is syntax for using a struct. Very easy. Use this as a dot operator to access the variables inside of it. I'm creating a season. I could have just said season S, but only in C++. So I'm making it so you can use this in Objective-C. So you'd say enum season S. If I want it to equal autumn, which is 2 down from the top, so it starts at 7, remember, this should print out season 7. And if I run it, it will actually have tested it. I will show you guys pretty soon. Static int index. I wanted a static int which gets declared once and saves its variable. Like, it doesn't just disappear when the function ends, because I was going to show something funny. My roommate was learning the code. He's like, what if can I recurse main? I'm like, I've never tried that. And he actually did it. So after this little do loop, I have an if index is equal to 0, recurse main, and increment index, so it doesn't happen again, and return, so it doesn't just go through. So let's just take a look. I've been talking kind of fast, so might as well. So this is hello world, season equals 9, which is 2 down from 7, just like I said. It has the for loop, and this is hello world again, so clearly it did recurse main. That was funny. Like I said, this is a syntax review for people that have been coding, and newbies can see what's going on. So recursion is essentially when a function calls itself, so it starts in from the top, but then it kind of digs into itself and it has to unfold itself. So after it gets to this return statement, the inside main quits folding in on itself, and then it only executes this stuff once because it's unfolded. It's kind of weird. It just digs into itself and then unravels itself is one way to think about it. So do loops execute once. Here's their syntax. I made it so this one literally just evaluates to false or 0. In C# and other languages, false is its own type, so you might want to get in the habit of not saying 0 for false. Objective-C does a nil type of thing. It's very cool, but I'm not going to explain it right now. Nil is kind of advanced for this. So cout for stuff just says, I'm going to print what's in the for loop. I equals 1, I is less than 3, so 1, 2, 3 evaluates to false, and it doesn't happen, which is why we saw 1 and 2. I made it go to the next line every time, so here's where it recurses and does everything again. Multiply 5 and 2, call the function that's defined, where is it, below or above? Yeah, below, so multiplies down here. Call the function that's defined above, and it should say 10 and 7. This is the syntax of if and else if, and then else. If this is true, do this, otherwise do that. And I just made them all 1 just to show one thing, which I'll show right now. I'll try not to say show too many times. So, if is true. And then this one is actually somewhere else. That's a switch statement. So of if, even though else if is true, it only does the if is true part. And else, so if neither of them are true, do that. So else if specifically executes only if this is false. If this is true, it kind of breaks off and doesn't do any of these. I noticed different behavior when I was coding in Objective-C, and I wasn't sure if it was just me or what, so it's good to test this. It shouldn't have executed both, but I don't remember. I use a bunch of different languages, so I'm not too sure exactly what happened. Also, look at this. Code folding. It's a feature of most editors. I'm in a free one right now. But anyway, so here's the syntax of a switch statement. I decide whether or not I want to use braces. Switch statements are only evaluating integer variables. Unless you're in C# or Java, then they can do strings. But anyway, switch one. Normally you'd put a variable here. You'd say case 3, 4, 5. You can say case 1 and 2, and it will do both. And fall through, actually, it does do both. We saw 1 and 2 do 2. So not only does it execute this, but it falls through to here. This is not possible in C#, and in Objective-C, it breaks no matter what, if I remember right. I read the manual anyway. And so like iPhone type of Objective-C, which is pretty much the only type people use, that will need the break statements in every single one. So its default behavior is like this, but I'm not so sure what would happen if you made it Objective-C++. So if you change the file name to .mm instead of .m, for those of you getting into iPhone Objective-C, go ahead and experiment. You can also read the manuals. I've read the whole Objective-C manual. So what I'm saying might be off, but what I'm saying has a basis somewhere, of course. Anyway, that's the switch statement. Ternary. So this ternary just means operating on three things. So the question mark operator, aka the conditional operator, also known as ternary operator, has three things. The condition, what it returns if true, and what it returns if false. This is just the syntax of it. It's very simple. A condition with a question mark after it, whatever's true, doesn't take a semicolon, which is weird. And then colon, whatever's false, semicolon. So 1 is less than 2, so whatever's true, it should evaluate to 1, and it won't return 2. So we can try this. So ternary evaluates 2. What does it say? Build and run. Ternary evaluates to 1, and then I didn't use an end line, so the next thing says pointer is blah. Alright, let's get into pointers. Okay, I just showed the syntax of an array. So it's very easy. Dimensions of the array, latitude, longitude, because I use x and y elsewhere. I didn't want to get confused. All values evaluate to 9, or get assigned 9 actually. So I'll show a use of an array later. I didn't actually use this anywhere. Okay, so pointer, declared using this, and you can do it multiple ways. You can do that, or you can do that. All creates a pointer. But if you create multiple variables, it gets confusing when you do this, because then e is a pointer, but then y and x are just integers. What about this? I actually don't know. But this is obvious. So yeah, this is why you want to put variables on different lines, especially if they are pointers. You don't know which ones are pointers, which ones are integers, which ones are floats, etc. Okay, so pointer to e is going to get the address of e. So the pointer to e, so the pointer by itself, which we saw was 0x4 or whatever, so it evaluates to an address. But the value is a dereferenced pointer, so the dereference operator, so this asterisk goes before the pointer, should grab the value that the memory address points to, aka e. And since we know it points to e, this and this should be the same, which is what we just saw, and I'll do it again. Lastly, the pointer's address is, I got that backwards. There. The address of pointer to e, which should be different than all the others. So pointer 0x47, and value is 5, aka 5. I didn't put a space there, so be careful about spaces. dereferenced. Lastly, the pointer's address is different than all the others because it's the address of the pointer itself. I didn't get into pointers to pointers because once you understand this, you should be able to understand the rest. Sometimes you got to think about it for a while. It comes in handy when you're when you're doing strings. So I created a dynamically sized array. One of my favorite songs that I can't actually listen to for very long, but anyway, I create a string with a word, and the string is, and I use a for loop, unsigned int. The compiler generated a warning because size of is always unsigned. So I got rid of just int and added unsigned, which makes sure it's always positive. Use the postfix++, which is ++ after ind. Cout string at index. So size of is very handy. You don't have to assign the you don't have to multiply str here, or size of string times whatever, because a char is a byte size. I believe if you had something larger than a byte, you'd actually have to multiply this right here to match the size of the bytes of the variable, which is inside the array, which I know sounds very confusing. Essentially, this is size of something related to bytes. If it's bigger than a byte, you have to multiply it by that change. Okay, so this should essentially go through the entire string, print out everything inside the string, and it does. You probably saw it say safety. The string is safety. Process returned, which means nothing more happens, and that is true. It returns 0. Float multiply, and that is a very fast, partially confusing, if not more confusing, review of C. What I would expect you to do is be familiar with these and look at the new Boston's tutorials. Highly recommend him for learning C. I went to cprogramming.com myself. There's c++.com, so cplus.com. Get tutorials on anything you don't know. If you feel you need something, read it, practice it. There's plenty of videos. This is the foundation for Objective-C. So understand these. This should be all you need to do to move on to Objective-C, at which I will have a slower, less confusing, more catering towards people that haven't programmed before tutorial. I might do C++, but I'm not so sure. It would have to be in a little while. Okay.